This assessment asks us to pick out which carbocations shown on screen we would expect to undergo rearrangement. Remember that carbocations will rearrange anytime we have a carbocation that is less substituted than its neighbor. And so what we're in essence doing is identifying the substitution of the carbocation and its nearest neighbors. And so we'll start with this one here on the left. It's a secondary carbocation flanked on both sides by secondary carbons. As a result, we do not expect this to rearrange. If we move over to this one, we now have a secondary carbocation. On the right side is a primary carbon, but on the left side is a tertiary carbon. In fact, this one would undergo rearrangement to make this more stable tertiary carbocation. Over here, we have a secondary carbocation next door, flanked on one side by a secondary carbon, and on the other, a quaternary carbon. Since secondary is less substituted than quaternary, we expect that this one will rearrange. It will rearrange to make this tertiary carbocation. So we'll go from this secondary cation to this tertiary cation by a methyl shift. This one here, we have a secondary carbon flanked on one side, or a secondary carbocation flanked on one side by a primary carbon, on the other by a secondary carbon. This one will not undergo rearrangement. And then finally, this one is one that we probably haven't seen anything like just yet. This is a secondary carbon that is flanked on one side by a primary carbon and on the other side by a tertiary carbon that also has a hydroxyl group. This one will undergo rearrangement, and the molecule that we're going to get will be this cation here. Now you might look at this and say, haven't we just gone from a secondary carbocation to a new secondary carbocation? In fact, we have, but this secondary carbocation is going to be stabilized by resonance. So anytime we can create a more stable carbocation by having either a hydride or alkyl shift, then the rearrangement will happen.